Hey everyone, let me know if I'm audible, guys. Let me know if I'm audible, guys. What's up, guys? What's up? बहुत दिन से नहीं मिले. बता दो if I'm audible. Let me know if I'm audible, guys. ऑडिबल तो पक्का 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 सबको बुला लो फटाफट बुला लो शुरू करते हैं. सो आज का क्लास टुडेज क्लास इज गोइंग टू बी वन ऑफ दी I want to learn everything about bit manipulation. Tomorrow I'll be busy, so what I've decided is today I'm going to take an entire session. Yes, entire session of probably 2 hours, 2.5 or 3 hours. Like, I have a lot of problems with me. Like, I've written down all the problems that we're going to discuss. We're going to learn all the tricks of bit manipulation and everything. So, do you guys have time till 12 o'clock or 1 o'clock in the morning or 12 o'clock in the night? Do you have time? टाइम है तो looking fresh. Yes, I just had a trip, so I'll look fresh now. Very enjoying, guys. Come on, quick. Cool. Perfect. So, for all the people who are new out here, my name is Raj Vikramaditya. I am known as Striver in the programming community. I'm a competitive programmer, and currently I'm working as a software engineer at Media.net DirectEye. Prior to this, I was working at Amazon, and I'm rated Candid Master at Codeforces, a 6-star at CodeChef. I have a couple of years of teaching experience, and I run a YouTube channel which has around 90,000 subscribers. The subjects that I take are competitive programming, data structure algorithms, C++, interview preparation. So just going forward, there are some batches on Unacademy that have been launched. The first one is the Transpire batch, which is having OS DBMS networking master course, which is going to be live on 20th July, and it has a duration of 1 month. The second batch is Eklavya 3.0, again a complete Java course, which is going to be live, or which has gone live on 21st of July. It's a 7.5 months duration. The third one is the Brahmastra 3.0, exclusive 5 months learning track for college slash off-campus placements, and it has gone live on 20th July, 5 months duration. The last one is the Mahayodha 2.0, again a 6-week master course on advanced programming topic, which has gone live on 20th July of a 2 month duration. Now, in case you want to take all these, like any of these batches, you need to take up a subscription. That is the competitive programming subscription. There are 12 months, 6 months, 3 months, 1 month, and you can take the plus subscription. The benefits that you'll get is India's best programmers, as well as the interactive live classes and doubt support after the class. Also, you'll get relevant hand-picked problems from CodeChef. And yes, if you are willing to take a subscription plan, do not forget to use the coupon code Striver in order to get a 10% discount on Unacademy. Now, a lot of people have been asking me, when is my course coming? The course is coming next weekend, so yeah, do stay tuned. We'll be making the announcement probably tomorrow. Like, yeah, the announcement will be made, so yeah, do stay tuned. Also, if you're new to this channel, you can definitely like the stream, share the stream, and subscribe to this and click the bell icon to get notified. So without wasting any time, how many of you know about bit manipulation? Whenever you take a subscription, do not forget to use the coupon code Striver, right? So if you just keep on using, then I'll be more activated on this channel, right? So that, cool, perfect. Screen visible, right? Perfect. So let's हाँ, शायद अभी कोई ऑफर भी चल रहा है 3 महीने का 4 महीना. चेक कर लेना सेल्स टीम के साथ. There is an offer, I guess. Cool. Let's get started. Let's get started with the stuff, bit manipulation. Now, whenever you say 10, okay, what is this? It's a decimal, right? It's a decimal. So whenever you write in computer, like something like int a equal to 10, the computer doesn't understand decimal. Like whenever you write 10, it's actually 10 to the base 10. It isn't 10 to the base 8, or it isn't 10 to the base 2, or 10 to the base something like 16. It is actually 10 to the base 10. We generally do not call this, like this is a silent we keep it silent. So any number is always written in decimal in our day-to-day term. Now when I talk about bits, every number can be binary represented. Yes, every number can be represented in binary. Now what is binary? Let's discuss about what is binary. ये ऐसा काय चल रहा है आज? Let's discuss what is binary. Binary is nothing but something like a 1 0, right? Binary means two digits, 1 and 0. So do you know how to represent 10 in binary? Yes. So if you want to write 10 in binary, like 10 to the base 2, and you want to write this in binary, that's nothing but 1010. That is what its binary equivalent is. Now what is this 1010? How do you get this? A very simple. Now I'll talk about the normal बच्चा वाला, like the school में जो पढ़े थे, ठीक है, the school में पढ़े थे. I'll just talk about that. So what I do is 10, I initially divide by 2. Okay, I initially divide by 2. So what will be the remainder? The remainder will be 0. Okay, so if I divide by 2, I'll be left out with 5. Perfect. Now again, if I divide by 2, what is the remainder? This time 1. And what will it divide with? 2. Correct. Again, I'll divide it by 2. So if I again divide it by 2, this time what will be the remainder? Obviously 0. So this will be a 0. Again, if I divide by 2, there will be a 1. So the moment you reach 1, you're going to stop. And this is the binary representation. If you look from the bottom till the top, from the bottom till the top, that is what the binary representation is generally. So something like 1010 is going to be your binary representation of any number 10. So if you have understood this, can you tell me what is the binary representation of the number 14? Let me in the chat box what is the binary representation of the number 14. स्ट्रीम को लाइक कर दो अगर नए हो, मतलब स्ट्रीम को लाइक कर देना. Tell me what is the binary representation of this. Yes. Can you quickly tell me what is the binary representation? 14 का binary representation क्या है? बहुत सही. Perfect Samart, perfect. Perfect Sujan. Perfect Tech JD. Prabhat, perfect. Sai, perfect. So if you try to divide 14, what you will get is 14 divided by 2. It will leave you a remainder 0. So again, this will be a 7. Again divided by 2 will leave a remainder 1. So this will be 3. This on division will give you nothing but 1. And this will leave a remainder 1. So if you keep on writing this, 14 will be 1110. Okay. So that's how you generally convert a decimal to a binary. That's how you generally convert a decimal to a binary. Okay, perfect guys. So now, so we have understood how to convert a decimal to binary. We'll come to the code aspect afterwards. But as of now, let's learn how to convert the vice versa. Let's, for an example, say that you have been given 1011. Okay, this is in binary and I want you to convert this into the decimal equivalent. Okay, I want you to convert this into the decimal equivalent. So how do you convert this? Very simple. What you do is you take this 1 and remember, in binary the bit indexing goes from right to left. It generally in arrays it was from left to right, but over here it will be from right to left. The decimal representation is from right to left. Remember this. Okay, so this is the 0th bit. This is the 0th bit. This is the first bit. This is the second bit. This is the third bit. Okay, so what is this bit? 1. So you'll do 1 into 2 to the power 0. Okay, this one will be 1 into 2 to the power 1. This one will be 0 into 2 to the power 2. This one will be 1 into 2 to the power 3. So once you have written all of these, what you do is you simply keep on adding them. So this is nothing but 1 into 2 to the power 0, that's 1. This is 1 into 2 to the power 1, that's 2. This is 0 into 2 to the power 0, that's 0. And this is 2 to the power 3, that's 8. So if you add all of these, 8 plus 2 plus 1, that's 11. So that's how you generally convert a binary into a decimal. So is this clear? Is this clear? Like as of now, I'm just teaching you conversions. I'll come to this code aspect afterwards, but yeah, as of now, just remember this as conversions. Perfect. Every bit represents a power of 2. This represents 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Remember this. That's how binary works. Binary 2, base 2. So 2 to the power 0, 2 to the power 1. Simple बच्चा वाला था. You'd have learned this, right? You'd have learned this while you were in class 9, 10, right? Perfect. Okay, perfect. So abhi we will start off with some iterate, like some operators, okay, and after that I'll slowly move on to the problems, but we need to learn operators, right? So thoda fast nahi kar sakte na, bahut beginners bhi hai. I think for people who are watching it, if you're thinking this is very slow, probably you can join after 15 minutes, ठीक है, क्योंकि I have to take care of everyone, right? So अभी इसके बाद जो पढ़ाऊंगा हो सकता है you don't know, and अगर जिनको आता है वो बोले थोड़ा पास, तो आपको बुरा लगेगा ना, है कि नहीं? ठीक है, perfect. So now we'll move to some operators. Okay, let's understand the operators so that we can actually solve every problem. So the first operator is the AND operator. So imagine we have couple of numbers. One is the A, the other one is the B. Okay, so what is A? A is let's assume A is 5, and let's assume B is nothing but 6. Okay, so I've taken A equal to 5, B equal to 6, and remember the operations of AND. Now whenever I say AND operator, it means all should be 1, all 1 means 1, okay, all 1 means 1, any 0 means 0. Remember this, all 1 means 1, any 0 means 0. Now if I write A and B, so ideally what computer does is it converts this 5 into a binary. So the 5's binary, if you write it, it will be 1 0 1, okay, and B is 6. So if I write 6 binary, it will be 1 1 0, okay. Now if I try to do an AND operator, what will happen is, let's check out the 0th bit. It's a 1, it's a 0, so we have a 0, right? We have a 0, so this will become a 0, right? Because any 0 is 0. Now if you check out the first index, we have a 0, right? We have a 0, so this will become a 0. Perfect. Now if I check out the next bit, it is having all ones. So if it is having all ones, this will become 1. So this is the resultant number if you do A and B, when A is 5, B is 6. So what is this number? 4. So A and B will produce you a number like 4. Now is it that you can only do an AND operation between couple of numbers? No. Assume you are given something like A equal to 5, B equal to 7, C equal to 8, okay. So in that case, if I write A and B and C, then what will happen is, A is 5, that's 1 0 1, B is 7, that's this, C is 8, right? So this time the operation is going to work accordingly. So again any 0, yes, again any 0, yes, again any 0, yes, again any 0, yes. So ultimately if you do an AND of this, the result that you'll produce is 0. So doesn't matter how many numbers you have been given. If it's 2 numbers, okay. If it's 3 numbers, okay. The main funda of AND operator is, if all are 1 or all are true, then it will be a true. If anyone is false or anyone is 0, it will be a 0. So is the AND operator clear? Is the AND operator clear to everyone? AND operator clear है? Okay, perfect. ठीक है, perfect. शुरू करते हैं, अब नेक्स्ट ऑपरेटर पे चलते हैं. So the next operator is, so you have understood the AND operator, right? Now it's time to understand the next operator, that is the OR operator. So this is what is known as the OR operator. So what is the OR operator? Let's understand this OR operator. Now whenever I say ki A is given as let's say 5, B is given as 7. Okay, so OR means anyone, yes, anyone is 1, all 0 is 0. ठीक है, इसका मतलब ये है anyone is 1, all 0 is 0. So if I take A equal to 5, so what is A equal to 5? 5 is 1 0 1. Okay, A equal to 5 means this, and B 7 means 1 1 1. So if I do an OR, so do you see a single one in this? Yes, you see. So this will be a 1. Do you see a single one in this? Yes, so this will be a 1. Do you see a single one in this? Yes, this will be a 1. So this is what the resultant will be. So this is what the resultant will be. So I hope you have understood. If anyone is 1, it will give you a 1. If all are 0, then only it will give you a 0. So the OR operator should be clear. If you have any doubts, you can put that into the chat section. If you have any doubts, you can put that into the chat section. Okay? Let's come to the next operator, that is the XOR operator. Now this is a kind of a new operator to you. So let me tell you how does this work. If I say even 1, yes, if I say even 1, that will be a 0. If I say odd 1, that will always be a 1. Remember this technique. Okay, if I say even ones, it will be a 0. If I say odd ones, it will be a 1. That is how the XOR property works. For an example, if I again take the example A equal to 5, B equal to 7, so A equal to 5 will be 1 0 1, B equal to 7 will be 1 1 1, right? So if I do a XOR, so over here at the 0th index, what do we have? We have 2 ones. What is 2? That's even. So if it's an even, that will generate 0, right? Over here, how many ones do you have? You have 1 1. 1 is odd, and if it is a odd, what will happen? This will become a 1. Let's see over here. Over here, it's an even number of ones, and if it is even number of ones, what will happen is this will come out to be something as 0. So the XOR, is the XOR property clear to everyone? Something to observe, that even number of ones will give you 0, which actually tells you, which actually gives you an idea that if the numbers are same. For an example, if the numbers are like A equal to 5 and B equal to 5, and you end up doing a XOR, the numbers that you'll get will be 0 0 0, because at every index you'll end up getting even number of ones. So if same numbers are XORed, the value that you will get will always be 0, because they'll cancel off each other. Perfect है? सबको आ गया समझ? Has everyone understood bit operations? बहुत सही. स्ट्रीम को लाइक कर दो अगर अभी ज्वाइन किए हो, ठीक है? Let's come to the next operator. Okay, so we'll come to the next operator. So the next operator that we will learn will be complement. Negation. Now what is this negation operator? Let's understand. So if you're given A equal to 1 0 1, okay, so if you say A equal to negation of A, or B equal to negation of A, so as the name suggests, negation, it will flip the bits. Negation operator means it will make 1 to 0, it will make 0 to 1, okay? It will flip the bits, it will make 1 to 0, and it will make 0 to 1. So remember, negation operator flips the bit. So basically, what will be the value of B? B will get 0 1 0, because A was 1 0 1. So 1 got flipped to 0, 0 got flipped to 1, and this 1 got flipped to 0. I hope that's clear. It's a negation of bits, it's a flipping of bits. So the negation operator is indeed clear. मैं फटाफट जा रहा हूँ, कोई दिक्कत नहीं है ना किसी को? अगर किसी को प्रॉब्लम हो रहा है तो बता दियो. लाइक आई एम गोइंग वेरी फास्ट. आई होप देयर इज नो प्रॉब्लम टिल नाउ. ठीक है, कूल. I'll come to that. ठीक है. So let's come to the next stuff, which is the right shift operator. Now what is this right shift operator? Now right shift means that whenever I say 5, okay, whenever I say 5 basically means 1 0 1. Right shift means if I say let's say A is 5, okay, 5's binary is this. So if I say A right shift of 1. So if I say A right shift of 1, so the last one bit will go off. So automatically if this goes off, you will be left off with 102. I hope you understand what I'm meaning to say. Basically what happens is, this goes off, this 0 will come here, this 1 will come here. So basically on the 0th index, now you have the 0, on the first index you have the 1. So basically 1 will go off and these guys will shift, right shift. This will topple over, this will go off, topple over. Is the right shift clear? Is this clear? क्या ये क्लियर है? Is this clear? Are the toppling over? I'll come with one more example. But is this toppling over clear? Everyone? Okay, so I'll give you one more example. Let's take one more example and understand the right shift operator. What if I give you A as 10, okay, and I ask you to right shift it by thrice. So what's 10 in binary? That's nothing but 1010. That is 10 in binary, correct? So I'm asking you to right shift by 3. So this topples over, this will go off and this guy will come over here. So ultimately I will have something like imaginary 00 bits and this one will come over here. So this is what will happen if you right shift it by 3. If you right shift it by 3, got it? अब क्लियर है क्या हो रहा है? It topples over. देखो ये 0, this 0 goes over, this 0 goes into the dustbin, this 0 goes over the dustbin. Right shift, ये देखो हाथ, boom, ये देखो हाथ आगे बढ़ा, आगे, तो ये 1 3 गुना आगे बढ़ा, ये 1 3 कदम आगे बढ़ा, 1 कदम 2 कदम 3 कदम, जस्ट आगे बढ़ गया. समझ में आ गया? Now remember one thing, this is equivalent to this, like both are equivalent, right? Both are equivalent. The left side of zeros will never contribute to your answer because they are zeros. Only one contributes to your answer. That's why if you write 0001 or if you write 1, both are same. ठीक है? ठीक है, क्लियर हो गया? अभी और डाउट है? Is there any doubt, guys? If there's any doubt, you can tell me definitely. आ गया तो सबको? आगे बढ़े? तब यस लिख दो फटाफट, मतलब बारिश कर दो यस के, आगे बढ़ते हैं. यस का बारिश कर दो, मैं आगे बढ़ता हूं एक शॉर्टकट बस बता के. So do you observe something? Now, do you observe something? What is the observance that you can see over here? When you had 5 and you ended up doing a 5 right shift of 1, the number that you got was 10, which is nothing but 2, right? And the moment you took 10 and you said 10 right shift of 3, the number that you get was 1. So if you observe, आँख अगर अच्छे से डालोगे तो क्या हो रहा है पता है? ये you're doing a 10 by 2, 5, again you're doing a 2, again you're doing a 2, 1. So whenever I'm asking you to right shift by 3, division of 2 happens thrice and you end up getting a number like 1. That is what happens. Why does that happen? I will tell you. ठीक है? Why does that happen? I'll tell you. So अभी बता दूं क्यों होता है. देखो, what was 10? 10 was 1010. That is what was the value of 10. Correct? Now, what this apparently means is Logically, think logically what this means. This means 0 into 2 to the power 0. This means 1 into 2 to the power 1. This means 0 into 2 to the power 2 plus this means 1 into 2 to the power 3. Everyone is agreeing? This is what the decimal equivalent is. Everyone is agreeing? At the moment you say this to topple, this to topple, this to topple. So ultimately this one will come here and these guys will be 0, 0, 0. This is what when you call right shift by 3 means. This is what right shift by 3 means. So ultimately you're saying this one to come here, which is 1 into 2 to the power 0. So if you carefully observe this one, this one was 1 into 2 to the power 3, and over here once it has been right shifted, what is the value? What is the change? It's a change by 2 to the power 3, isn't it? It's a change by 2 to the power 3, isn't it? Isn't it? Isn't it a change by 2 to the power 3? How many of you agree with this? How many of you agree with this? Isn't it a change by division of 2 to the power 3? The power reduced. Every time there's a 1 shift, the power is gonna reduce by 1. The 2's power is gonna reduce by 1. That's why the number of times you're being asked, to right shift, that's equivalent to saying whatever is your decimal number, that divided by 2 to the power number. Clear hai? Clear hai? Is this clear? Yes, yes, everyone did understand this. Did everyone understand this? सब यस नहीं बोल रहे, सब यस नहीं बोल रहे, क्या हो गया? पंगा हो गया क्या? Is everyone not giving me yes? Is there a doubt? If there's a doubt, you can tell me. अरे यस, मैं जब पूछता हूँ यस तो झड़ी लगा दिया करो, मतलब तब फिर कॉन्फिडेंस मुझे भी आता है. Okay, so I've given you the intuition why whenever someone says right shift by 3, that means divided by 2 to the power 3. Why someone says, I've given you the intuition, right? Perfect. So we have also now discussed the right shift operation. Now it's time to discuss the left shift, obviously. Okay, now we'll come to something which is known as the left shift operator. Again, I hope you have understood now. Till now, I think you have understood. Now, whenever I am saying right shift, first of all, let me tell you something. Whenever you write integer a equal to 5, what is integer? Remember, integer means 32 bits. Integer means 32 bits. This 5 is in decimal. The corresponding binary is actually 0, 0, 0, 0. Ideally, this is the corresponding binary is ideally this. It's not 101. It's actually these many zeros, and this total number of guys are nothing but 32 bits. The total number of guys are nothing but 32 bits. Yes, this total number of guys are nothing but 32 bits. Remember this. Yaad rakhiyo. All important at least. There's nothing but 32 bits. Yeah. So whenever I say 5, why don't you left shift by 2? What happens is, अब left का topple over होगा. This guy will topple over. This guy will topple over. When I say left shift of 2, this 0 will come here. This 0 will come here, and so on. This 0 will go. This 1 will go. This will go. So ultimately, this will become 101. Since I'm saying move by 2 places to the left, so left move kar dega. So on the right there will be couple of zeros addition. Got it? Is this clear? Is this clear, guys? Kya ho raha hai? Simple enough. If you can correlate from right shift, I think this should be an easy one. राइट, क्लियर है? So what is this? This is 101. So for this one, it's a 1 to the power 2 to the power 0. For this 0, it's a 0 into 2 to the power 1. For this 1, it's a 1 into 2 to the power 2. Correct? Right? This is what this is. Over here, this one has moved here. See the iteration change. This was at 2 to the power 0. Now it has moved to 2 to the power 2. So how many change it has happened? How many change it has happened? Now this one is getting multiplied by square instead of 2 to the power 0. So what is the change? Can I say the change is 2 to the power square? Can I say the change is 2 to the power square? Got it? So do you observe? So can I say, whenever I say the right shift, it actually means 5 into 2 to the power 2. This is what I mean whenever I say left shift of 2. Is that clear? Yes लिख दो, yes लिख दो, आगे बढ़ेंगे. Yes लिख दो, आगे बढ़ेंगे. और एक ऑपरेटर हो गया. अपने के लिए राइट, अपने के लिए लेफ्ट. आज आवाज बहुत तगड़ा आ रहा है क्या? वॉइस इज ऑसम सर. आज आवाज बहुत सही आ रहा है क्या? What happens after 32 bits? If you do a right shift, nothing will happen, right? If you keep on dividing, it will be 0. But in case of left shift, remember, in case of left shift, this will overflow. If you do a lot of left shifts, like if you are having an integer a equal to 30, like if you do 5 into 2 to the power 50, don't you think that this will overflow? Because an integer only stores value up to 2 to the power 31. Like last wala jo number hai, it stores the value up to this much. So if you just keep on multiplying this will tend to overflow and it will give you a negative value. So overflow ho jayega, ठीक है? किसको डाउट है भाई अभी? Bro, 10 how the thing explained on 10 is applied to 5. क्या बोल रहा है भाई? I've told you this is a negation operator. There's a negation operator. This is a negation operator. Flip bits makes 1 0 makes 0 1. ठीक है? आई थिंक एक दो जिनको कमेंट्स में प्रॉब्लम हो रहा है तो हेल्प कर दो उनको हेल्प कर दो, ठीक है? क्लियर है? तो किनको वंस मोर चाहिए क्या? किसी को वंस मोर चाहिए क्या? लेफ्ट राइट शिफ्ट. डू यू नीड वंस मोर? हाउ इफ यू नीड वन मोर एंड क्लियर कितना लोग है? क्लियर लिख दो एंड जिनको वंस मोर चाहिए वंस मोर लिख दो. Tilde operator flips bit. Yes, when you divide, you should only consider quotient, not remainders. NAND और खुद से कर लेना. It's a mixture of OR and gets. Once more कितने लोग हैं? I think एक दो जनी है. For people who are saying once more, ज़्यादा लोग नहीं है once more का, तो एक काम करना, you can just re-roll it back, क्योंकि फिर बाकी लोग का टाइम वेस्ट हो जाएगा, ठीक है? So just make sure you re-roll it back, ठीक है? परफेक्ट, ठीक है, बहुत सही. once more, अरे खुद से कर लो आप. 1 सेकेंड जिनको है वो खुद से कर लो, ठीक है? चलो आगे बढ़ते हैं. और अरे ब्रो 5 राइट शिफ्ट ऑफ 1. अरे भाई तू इतना सारा स्पैम मत करियो, मैं तेरे को बता देता हूँ. देखो 5 राइट शिफ्ट ऑफ 1 का बोले तो क्या है? 5 क्या है? 101. राइट शिफ्ट ऑफ 1 बोले तो एक को भगाना, एक को भगा. चलो इसको भगाओ तो ये टॉपल ऑफ हो जाएगा तो ये प्लेस खाली हो जाएगा, है कि नहीं? खाली हुआ. अब खाली हो तो ये बंदे क्या करेंगे? ये राइट जाके भर लेंगे. तो ये 0 गया इधर जाएगा तो ये खाली हो गया, राइट? नेक्स्ट स्टेप पे ये खाली है तो ये क्या करेगा? इधर जाएगा तो ये हो जाएगा एंड ये फिर खाली हो जाएगा तो ये जो 0 था इधर जाएगा. ऐसे कर करके सब हो जाएंगे तो अल्टीमेटली तुम्हारे पास 0 0 0 0 0 1 0 हो जाएगा. समझा? राइट शिफ्ट. दिस इज नथिंग बट 2. इसलिए मैंने बोला 5 डिवाइडेड बाई 2 होता है तो 2 ही आएगा. 2.5 पॉइंट नहीं आता है, 5 होता है, ठीक है? चलो Okay, so operators are clear, right? Operators are clear. So we will move on to doing something very, very important. Now we are going to use these operators to solve something. We're going to use these operators to solve something. The first question will be, imagine you're given an array of integers. Imagine you're given an array of integers, and the array of integers are containing numbers like 2, 1, like they can contain any numbers. So these are the numbers. So in the array, every integer occurs twice, okay, and one integer occurs once. One integer occurs once. You print that one integer. You have to print that one integer. Is this question clear? Like over here, the 2 is appearing twice, this 5 is appearing twice, the 6 is appearing twice, the 7 is appearing twice. So the number that is appearing once is 1. So the answer should be 1. Clear a question? Clear a question? अरे spam मत करो, spam मत करो. No spamming, guys. How will you do this? Come on, let's see who can answer this. Okay, Adarsh is saying XOR property. Why Adarsh? XOR करेंगे. Okay, सबका XOR. Okay. Okay, okay. बहुत सही, बहुत सही. क्यों XOR होगा? XOR क्यों होगा? Why will it be a XOR? XOR of all numbers. Perfect, perfect. Easy है. आगे बढ़ते हैं. So basically, understand. Since I'm saying every number occurs twice. Okay. So if I run a for loop and I say something like this, I equal to 0, and I go until n, and I do I plus plus, ठीक है, and मैंने एक XOR कर दिया 0, so and I do XOR equal to XOR with a of I. So ultimately if I print XOR, understand, ultimately if I print XOR, I will get, this is what the single number is. This is what my single number is. Why did this work? Because first you did 2, so it was a 2 XOR 1 XOR 2, so 2 उड़ गया, 2 उड़ गया रे, उड़ गया. फिर 5 भी उड़ जाएगा, 6 भी उड़ जाएगा, 7 भी उड़ जाएगा. So ultimately whatever will be left will be your singular number. Is that clear? सबको आ गया? सब कैंसिल आउट हो जाएंगे. ये जो अकेला नंबर है वो अकेला रह जाएगा, एंड वही नंबर मेरा नंबर होगा. क्लियर है? Perfect guys, perfect. Well, now we'll move to some interesting properties, and after that I'll come back to questions. और एक इंटरेस्टिंग क्वेश्चन है, बट आई विल फर्स्ट डू सम अदर क्वेश्चंस ऑन XOR, और 2 क्वेश्चंस करते हैं XOR पे, फिर बढ़ते हैं. ठीक है? सो इज दिस क्लियर? सही. रिपीट कर दो क्विकली. अरे रिपीट क्या करना है? when I'm saying XOR of all the array numbers, so when you do a XOR, since numbers appear twice, the twice numbers will get cancelled because same numbers का XOR 0 होता है. तो सारे twice numbers, 2 and 2 will get cancelled, 5 and 5 will get cancelled, 6 and 6 will get cancelled, 7 and 7 will get cancelled. तो बचेगा क्या? 1 बचेगा ना, 1. समझा? स्पैम मत करो यार, स्पैम मत करो. मैं एक AMA सेशन रख दूंगा, उधर स्पैम करना. ठीक है? ओके, नाउ कमिंग टू अ वेरी सिंपल कॉन्सेप्ट, व्हिच इज स्वैपिंग ऑफ 2 numbers using XOR. Swapping of 2 numbers using XOR. Okay, so imagine I give you a equal to 5, I give you b equal to 7. Okay, so I want you to swap these 2 numbers. I want you to swap these 2 numbers. How will you swap these two numbers? Can you tell me how will you swap these two numbers? कैसे करोगे swap? That was not the question, Avani. That was not the question. Let's go question wise. The questions that are solvable using bitwise, I'm going to do those questions. The questions which are not solvable using bitwise, there's no need to do that because it's a bit manipulation class. Okay? I want you to swap the two numbers. So how will you swap the two numbers? It's a very simple funda. Dekho. If you write a equal to a XOR b. So currently, what is the value of a? A is no more, like currently if I say step 1, on step 1, what is the value of a? A is 5 XOR 7, right? On the next, as of now, on the step 1, b is 7. That's on the step 1. On the second step, I say b equal to, right, I say b equal to a XOR b again. Okay, I say a XOR b again. So on the second step, what will be happen? B says a, what is a? 5 XOR 7. What is a? 5 XOR 7. So 5 XOR 7 XOR b, what is b? 7. So b XOR 7, and what will be a? A will stay as it is, that is 5 XOR 7. So b will deduct 7, 7 will deduct. So the step 2, b will be 5, a will be 5 XOR 7. Again at the step 3, if you perform a equal to a XOR b, what will happen? On step 3, a means, I'm saying a, what is a? 5 XOR 7. 5 XOR 7. What is b? B is 5. So 5. So 5, 5 will get cancelled and it will be a 7. And b will stay as it is, that is 5. So can I say after step 3, a will have a value 7, b will have a value 5, and initially it was the opposite. So can I say I have swapped by performing these 3 steps? Clear hai? 3 steps clear hai? Is this clear? काफी लोग को पता है. नो इश्यूज, नो इश्यूज. रिवाइज हो जा रहा है जिनको पता है. क्लियर हो गया? इज दिस क्लियर टू एवरीवन? इज दिस क्लियर टू एवरीवन? हेयर स्टाइल का तो बैंड बज चुका है. Anyone? A XOR 0 is equal to a. Yes, a XOR 0 is equal to a. Nakul?
Here's what I found.
Sure, sure, Kunal. Yes, yes, these things रिपीट नहीं है. ये 3 स्टेप लिख लो. ये 3 स्टेप लिख लो, बाद में समझ लेना, बाद में खुद से हाथ से करना. Just take these values and do step wise. You'll get to know this. ठीक है? You'll get to know this. Take these. ठीक है? Okay, perfect. Okay, everyone has understood swapping of two numbers. So this is a very famous interview question in a lot of companies like TCS, Infosys में बहुत बार पूछा आता है. How to swap two numbers without using a third variable. So this is the methodology that you should definitely give. If they're asking you how to swap two numbers without using third variable, ये बोलना है. ठीक है? अरे खुद ग्रैंड मास्टर नहीं बना, तुमको कैसे बनाऊं? I can teach you till how much I've reached. And I think that is only possible to be taught in 3-4 months, not more than that. Someone becomes a grandmaster by himself. Yes, someone becomes an expert by, probably, if someone teaches, you can at max become an expert level. But if you're wanting to go beyond expert level, that will be completely dependent on you. Like no one can teach you to become a grandmaster. It will be completely your stuff. Yeah, someone can teach you to be a very good coder, like a specialist or an expert. Okay? Perfect. आगे बढ़ते हैं. So this question is also done. Now I'll give you a very good question. Given n, let's see who can solve this problem. ये कोई नहीं कर पाएगा. Given n, print the XOR of all numbers between 1 to n For an example, if the input is 5, the output should be all the XOR from 1 to 5. That's 1 XOR, 2 XOR, 3 XOR, 4 XOR, 5. So 1 XOR 2 is 3, 3 XOR 3 is 0, 0 XOR 4 is 4, 4 XOR 5 I think is 1 0 0, 1 0 1 XOR है ना, तो 1 0 0, yeah, 1 है. So the output should be 1. So if we do a XOR of these, the output comes out to be 1. Question clear? Is the question clear? Is the question clear? Question clear है? यस यस यस, बताओ कैसे होगा? Yes, obviously not with loop. Obviously I don't want this solution, man. What do you expect? I don't obviously don't want this solution, man. For people who are thinking I want the solution, I think you need to, yes, you need to that. Man, how can the complexity is big O of n. I don't want a big O of n solution. I want something better. ना 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 ना, ये नहीं चाहिए भाई, ये नहीं चाहिए, ये थोड़ी पढ़ा रहा हूँ. I want you to, yes, I want you to write some answers. So always remember, in questions like this, always remember, in questions like this, try to figure out a pattern. Try to figure out a pattern, right? So let's see. Let's try to figure out a pattern. ठीक है, क्या आता है? Obviously not big of n solution. I don't need this solution. ये solution अपन को नहीं चाहिए ना, ये I don't want this. No way. I don't want this. Let's see. Let's try to figure out a pattern. ठीक है, चलो चलिए शुरू करते हैं. गुरुजी के भाषा में शुरू करें. चलो. So let's have n equal to 1. What will be the answer for this? 1. Let's have n equal to 2. What will be the answer for this? 1 XOR 2. That'll be 3. Let's have n equal to 3. What is the answer for this? 3 XOR 3. 0. Let's have n equal to 4. What will be the answer for this? 4. Let's have n equal to 5. What will be the answer for this? 5. Let's have n equal to 6. What will be the answer for this? 7. Let's have n equal to 7. What will be the answer for this? 0. Let's have n equal to 8. The answer for this will be 8. So if you keep on writing, something you'll observe. There is a pattern of 4 forming. There's a pattern of 4 forming. Have an observation. There's a pattern of 4 forming. Where I can say, like, if I just start off with this. For all multiples of 4, can I say the answer will always be, can I say for all multiples of 4, the answer will always be 0? How many of you agree with this? You can keep on writing. You'll find for 12 also the answer is this. Right? For 5 it's 1. 1 है क्या? अच्छा, sorry. 5 it's 1. Sorry. 5 it's 1. Okay. So is this clear? ये 4 वाला फंडा clear है? Is this 4 वाला फंडा clear? Yeah, I got that corrected. Thanks Sai, thanks Nitin, thanks Nancy. Perfect. 4 वाला clear है? बता दो. रिपीट नहीं, ये देखो. इफ यू राइट, आकाश जस्ट ट्राई टू राइट आंसर्स. पहले n इक्वल टू 1 का आंसर लिखो, n इक्वल टू 2 का लिखो, 3 का लिखो, 4 का लिखो, सबका लिखते जाओ. तुमको दिखेगा जो 4 के मल्टीपल्स है ना, वो सब में ना 4 ही आंसर, सॉरी प्रिंट एनी आंसर आ रहा है, सॉरी प्रिंट एनी आंसर आ रहा है, एनी आंसर आ रहा है, सॉरी एक्सट्रीमली सॉरी, प्रिंट एन आ रहा है, एन. ठीक है, प्रिंट एन, ठीक है. Yeah, it should be 4. It should be 4. Print n. Print n. It will be print n. Yeah. Right. Print n is done. So this is done. Okay. Up. Let's have some other observance. Now, if you look at this, if you look at these guys, have a look at this. Can I say this is nothing but n modulo 4 equal to 1, and in this case the answer is 1. Indeed, if you carefully observe, the answer is 1. Perfect, that's done. Let's check this out. Let's check the next one out. If I observe, for n equal to 2, for n equal to 6, what's the answer? बताओ बताओ, चैट पे बताओ सब, क्या आंसर है नेक्स्ट वाले के लिए जब 2 मॉड्यूलो बताएगा तो. Right? And can I say for this it's a 0, for this it's a 0. So yeah, I think I figured out my answer. This is my code, and this is a BIGO of 1 solution. No matter how big is the n, I can actually answer it in BIGO of 1. No matter how big is the answer, no matter how big is the value of n, I can answer that in BIGO of 1. Isn't that guys? No matter कितना बड़ा है, कितना बड़ा है मतलब n की वैल्यू कितना बड़ा है, we can answer that in n plus 1 exactly, right? Perfect. सही जा रहा है क्लास, बहुत सही आ गया ये समझ. परफेक्ट. आकाश यार बाद में स्पैम करियो, स्पैम नहीं, इतना स्पैम नहीं, ठीक है. Okay, I'll give you one more question. Now let's see if you can have your brains up and you can implement something that I've taught you. Okay, let's have the next question. मिटा रहा हूं. Next question. Given a range, ठीक है, अरे एल सिर्फ कुछ भी यूज कर लो यार, कर लो अपने से. Given a range LR, print the XOR like L XOR L plus 1 XOR L plus 2 XOR R minus 1 XOR R. I want you to print this. For an example, L is given as 2, R is given as 4. The output should be 2 XOR 3 XOR 4. Like this should be the output. Got it? I hope that's clear. That's nothing but 1 0 1 1 1 0 0. That's 1. That's a 0. That's a 1. That's 5. So the answer for this should be 5. Clear? Hai? Question? Is the question clear? The pattern repeats for 4. The pattern repeats for 4 Finster. That's why. I'll bring up a time complexity video. तो अभी next week एक काम करता हूँ, मैं टाइम कॉम्प्लेक्सिटी पे एक डेडिकेटेड वीडियो क्लास लेता हूँ, एक 1.5 घंटे का, पूरा टाइम कॉम्प्लेक्सिटी को निचोड़ के समझा दूंगा, ठीक है. बताओ कैसे करोगे? Tell me how will you do this? Obviously this is not a pattern. How do you know this is not a pattern? Because over there n was constant, right? Over here the value of L and R can change. Over here the value of L as well as R can change. So like for how many values of LR will you determine the pattern? So you need to really think. You know the XOR properties. You're gonna use that. Just have some brains, guys. सोचो. भरत यार, perfect. भरत आर्यव्रत, OP यार, OP. भरत OP, बहुत सही. भरत OP. डिवाइड नहीं आकाश. Yes, 0 0 1. The complexity that I require is big of 1. I don't want you to run a loop. Definitely I don't want you to run a loop. No, 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 Sumit. No. No, Sumit. Perfect Lakshya, Lakshya OP, Lakshya OP. Perfect Lakshya. टाइम दो, ठीक है, चलो देते हैं. Question is, given a range LR, I want you to give me the XOR between that range. Like if L is 2, R is 4, I want you to give me 2s or 3s or 4, the overall value of 2s or 3s or 4, where 2 is L, this is R. Okay? No, Sumit, no. Time complexity पे फर्क पड़ेगा नहीं, रिकर्शन भी नहीं. सोचो. परफेक्ट आकाश. परफेक्ट परफेक्ट. नहीं, प्रीफिक्स नहीं, थोड़ा लॉजिक लगाओ, थोड़ा लॉजिक लगाओ यार, इजी है. No, no, Ashish, no. There's a bit of mistake. There's a bit of mistake. Ankita, perfect. Ankita, perfect. नहीं, no Hindi, no Hindi, no Hindi. Okay, let me tell you the answers. So, don't you think you have answers? Like for an example, I ask you to give me from 2 to 6, or let's say 3 to 6. Now, when you say, can you actually find XOR of 6 using the first technique that I taught you? Can you actually find from 1 to 6 का XOR? Can you actually find 1 to 6 का XOR? You'll be like, yes, 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 खोज सकता हूँ ना, अभी तो सीखा था. 4 का पैटर्न अभी तो सीखा था. Can I say, can you find the XOR till 2? You'll be like, yes, अभी तो सीखा था, वही मेथड लगा दूंगा. You just now learned, you'll apply that method. Now, what if? I write XOR of 1. So what is XOR of 6? That's actually the value of 1s or 2s or 3s or 4s or 5s or 6. That is actually the value of this. 1s or 2s or 3s or 4s or 5s or 6. Indeed. What is XOR of 2? 1s or 2s or... Now, what do you require? 3 to 6. What is 3 to 6? 3s or 4s or 5s or 6. So, how will you make sure that this one, this two, this one and this two cancel off? How will you make sure that this one, this two, this one, this two cancel off? Similar numbers कैसे cancel होते हैं? अरे बब्बरे XOR मार देंगे. So if I do a XOR between them, can I say the similar numbers will cancel off, and ultimately I will be actually having the value that I require? So can I say if this is L and if this is R, can I say I'll have to find a XOR till R, and I need to do a XOR till L minus 1. Can I say this? Can I say this is a BIGO of one solution, and you know how to find a XOR of R, you know how to find a XOR of L minus 1. Is this clear? Is this clear? Yes, yes, या फिर कुछ भी OP भी लिख सकते हो. OP लिख सकते हो चैट में अगर समझ में आ गया. Right, OP if you've understood this. Definitely. Perfect, guys. चलो सही. Clear तो. Okay, everyone has understood. Perfect. Say. This type of thinking will only come by practice, by solving a lot of bunch of problems. Otherwise, these kind of logics are very tough to come. ठीक है. चलो आगे बढ़ते. तो XOR का I've done a lot of questions on XOR. Like I personally feel I've done a lot of questions. So I'll now move to a very simple use case of AND operator. Okay. So if I give you a number, like if I give you n, okay, and I tell you check if a number n is even or not, is odd or not, for an example, how do you generally do? Given n, check if n is odd or not. This is how you do. This is how you generally do. You say this is even, or else you say this is odd. This is your code, correct? This is your code, right? Now, is this first overpowered? OP means overpowered. So this is how you generally do, right? So is this way good? Yes, this is good, but is this fast? No, this is not fast. The fastest way to do this is this. If n and 1 equal to 0, this is even, else this is odd. You use bit operations. Over here, oh, I'll tell you why. Over here, you're using a modulo operations, okay? You're using a modulo operation. Over here, you're using an AND operation, okay? Now, AND operation is way faster than a division, multiplication, modulos, these kind of operations. So this is way faster. This is this takes lesser time. Ulta, this takes lesser time. Now, why does this work? Now, I'll tell you one thing. Every number is actually formed with powers of 2's. For an example, if I take 12, when you write 12, you actually write 1 1 1 0 0. This is what you write when you write 12, right? So what is this? This is nothing but you're combining 8 plus 4, correct? So if you're writing 13, since this is an odd number, what happens is the last you are basically writing 8 plus 4 plus 1. In order to make any odd number, when you're adding powers of 2's, in order to make any odd number, since you're adding powers of 2's, you have to add a single one. You have to add 1. So in powers of 2's, the only power of 2 that is 1 is 2 to the power 0. Agreed? The only odd number of power of 2 is 2 to the power 0. Hence, the last bit of any odd number will always be set. Hence, when you do an AND with this one and this one will give you a 1, and rest of this is this. So, and if it is an even number, 1 1 0 0, and you do an AND with 1, this will give you 0, because in even numbers the last bit is not set, whereas in odd number the last bit will always be set, because you need a 1 in order to form an odd number. Clear है? ये सबको पता था क्या? Looks like सबको पता था. सही है. A lot of people already knew that. ओ भाई साहब 3 डिसलाइक, कोई बात नहीं, सह लेंगे. क्लियर है? तो 25 Akash is 16 8 0 0 1. There's 25. The last bit is always set, because 25 is 16 plus 8 plus 1. ठीक है? हाँ, बता देंगे, सब बताएंगे, ठीक है. So अभी तक we have learned about a lot of stuffs. Now we will come across to learning some basic stuffs. Then we will go back into learning some properties. Like I have a lot of other problems, but I'm not sure if I'll fit in time. अगर आप लोग 2.5-3 घंटा सेशन करना चाहते हो, मैं करूँगा पक्का से. जब तक मेरा ये है तब तक करते हैं. Like the moment I see audience are dropping off, I'll end the class. Till then I'll keep on teaching. Okay? अभी आते हैं सबसे important चीज पे. कुछ properties है, like there are 7-8 stuffs that I'll quickly ramp over, and this will be required to solve a lot of problems. Okay, the first one is, what if I ask you to check if you're given an n, okay, you're given an n, you're given an I, okay, given an n and I want you to check if the ith bit is set or not. If the ith bit is set or not. So what does this mean? Basically, imagine if I give you n equal to 13. Okay, what is 13 in a binary? That's 1101, right? So if I give you I equal to let's say 2, so what I'm asking you is the second bit set? So which one is the second bit? This one. So you'll be like, yes, it is set. But what if I give you I equal to 1? So is the first bit set? No. So for I equal to 1, the answer will be no. For I equal to 2, the answer will be yes. Question clear hai? Is the question clear hai? कैसे करेंगे? How will you do this? How will you do this? Yes, Kunal. Perfect, perfect, Kunal. Okay. Perfect, Finster. Perfect, Nakul. He had some problems. Naman Bansal's videos had some problems. So वो अभी हटाए गए. He'll be back streaming live. Thank you Mohit for liking my teaching style. ठीक है, अभी सोचते हैं अपन को क्या करना है. Imagine the number is let's take any arbitrary number. ठीक है, कोई arbitrary number ले लेते हैं. Let's take this is the arbitrary binary. Now what are the bits? Bits are 0, first bit, second bit, third bit, fourth bit. Now just think. If I am willing to check any bit like this third bit, I want to check if this third bit is set or not. Don't you think the best way to do that will be to place a 1 here, correct? And place all zeros over here. Like I can call this as a mask. Don't you think this will be the best possible way to do this? Like I set 1 over here, and this is what I do. And right over here, after that, I create a mask, and I will do a mask and n. So if I do an and with this guy, 1 0 0 0 0 0 0 0 0. If this bit is set, the mask will make sure 1 and 1 will be 1, and if this bit was not set, the mask would have made sure 0 and 1 would have been 0, 1 and 0 0. So can I say this will be a non-zero number if the third bit is set? What if the third bit was not set? Just in case the third bit was not set and the mask would have been something like this. In that case, when you do an AND, the every number will give you a 0 and this will become a 0. So can I say if I'm able to create a mask and I do a AND, and if this number comes out to be non-zero, I can say yes, and if it comes out to be equal to 0, I can say no. Yes or no? बोल सकते हैं? Can I say this? So कह सकते क्या? अभी मास्क कैसे बनाएंगे? How will you make this mask? That's the ultimate question. How will you make this mask? So can I say if I have been asked to check the third bit, I'm actually looking to place over a 1 here. If I've been asked to check the third bit, I'm actually placing a 1 at the third bit, which is equivalent to saying if I start off with a 1, just imagine if I start off with a 1 and I ask it to shift it by 3. If I ask it to shift by 3, don't you think this will be this 0 0 0 1? This one will shift 3 places and it will come here. Don't you think? Right? Indeed. So can I say my mask, if number is n and I have a I, can I say the mask will be 1 left shift of I? Yes. And I can say Boolean set can be easily mask and n, and the Boolean set will be my answer. Can I say this is my answer? Yeah, this is my answer. Agreed. सब समझ में आ गया? सबको आ गया समझ? आकाश देखो, कुछ नहीं करना है तुमको। ये थर्ड बीट के नीचे एक वन डालना था ना, थर्ड बीट के नीचे वन डालना था ना, तो तुम क्या किया, तुम वन लिया, तो वन को बोला भाई शिफ्ट हो जा 3 डायरेक्शन, तो वन क्या किया, पहले वन इधर था, 3 घर शिफ्ट हो गया, तो 3 घर शिफ्ट हुआ तो थर्ड बीट के नीचे आ जाएगा ना। अब तुम ऐड करेगा तो पता चल जाएगा, है कि नहीं? राइट। परफेक्ट 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 परफेक्ट। So this is how you check if the ith bit is set or not. ठीक है? This is right, Ankesh. This is also right. But the problem is, don't ever do anything with the n. Remember, remember this, guys. Always don't need to do anything with the n. Always try to create a mask. That should be your first criteria. Never ever alter the data that is given to you. You can never ever alter the data that is given to you. Okay, perfect. भाई आकाश, तुम जानबूझ के 2 बार पढ़ाने बोलता है, पता है, डबल मेहनत करा रहा है तुम आज। ओके, सो we are done with check with ith bit is set or not. Now next question. Next question is extract the ith bit of a number. I ask you to extract the ith bit of a number. That means, imagine again, I tell you 13 and I ask you I is 3 for that example. So 13 is 1's 0 1, like क्या था 13, 8 4 था ना, 8 4. So this is 13. So 0 1 2 3. So the third bit is set. The third bit is 1. The third bit is 1. So I want you to print 1. So I just want you to tell me, like, it's similar to bit is set or not. Similar here. Question quota. Similarly question, extract the add bit. This is similar to bit is set or not. So इसको ignore करते हैं. Let's come with the next question. Whatever I tell you, you have to set the ith bit. You have to set the ith bit of a number. It can be set, it can be not set, but you have to make sure that you make the ith bit as 1. For an example, if the binary is this, okay, and i's are like this, and I tell you I want you to set the second bit. I want you to set the second bit. So after setting the second bit, this will become 1 1 0 1 1 0. This is what I want. Got the question? Got the question? इसको कैसे करेंगे? इसको कैसे करेंगे? Create same mask but do odd operation. Perfect, perfect. अरे मैं 5 मिनट का ब्रेक लूंगा तो फिर मेरे पर सब चढ़ जाएंगे. अगर सेट हुई तो कुछ नहीं करेंगे, else to. Okay, okay, okay. Again, create a mask. Don't you think creating a mask will help you? Don't you think creating a mask will help you? Indeed, indeed, you're correct. If you create a mask, where you set this guy and you make sure all of the guys are 0, and after that, if you do an OR operation, don't you think this will end up becoming 0 1, whatever are this? If this is whatever this is, if this is 0, if this is 1, doesn't matter. Since you're putting a 1 here, this will make this 1, right? Perfect, perfect, perfect. So can I say the mask will become 1 left shift of I, and your number will become n equal to n or of mask. So this is how you will set the ith bit. Perfect, guys. Perfect, perfect. सही जा रहे हो यार, बहुत सही. Okay, now we will come across to another question. So I want you to clear the ith bit. I'll just change the question to a bit. I'll just change the question to a bit, and I want you to clear the ith bit. I'm not sure if this is set or not. Like the bit might be set. For an example, 110010, and if I is given as 2, which is 012. So after clearing, the number still stays same. The number still stays same because this is already cleared. Okay? And now, what if I give you 110010? Now I give you a value like I equal to 4. So in this case, 0, 1, 2, 3, 4. So if you clear that, this will become 100010. Got it? Got the question? Got the question? Yeah, I'll come to that. ये कैसे करेंगे बताइए मुकेश. Okay, perfect. Okay. Looks like a lot of people know this. Okay. Perfect, Mukesh. सही है. Clear the ith bit. Palak, question is clear the Rabi. Question is clear the ith bit. Doesn't matter whatever is that I. Like it can be a 1, it can be a 0. You need to make sure that is made 0. Clear it. Make it 0. Okay. How will you do this? Okay. Let's logically think. So in this example, you have a 1, 1, 0, 0, 1, 0. Correct? Now, what you will do is, you will simply, you want to clear this bit, right? You want to clear this bit. So, can I say, if I do a AND with a 0 here, if I do a AND with a like 0 here, whatever is over here, if it's a 1, if it's a 0, that will never matter. And an AND will make sure this is 0. Correct? Because I'm doing an AND with 0. And everywhere else, if I put in a 1, everywhere else, if I put in a 1, and if I'm doing an AND, if it's a 1, it'll automatically be 1. If it's a 1, it will automatically be 1. If it's a 0, it'll be 0. If it's a 1, it'll be 1. If it's a 0, it'll be 0. Can I say this is what will happen? Right? Correct? So, Abhi, what is this? Like, this seems very similar to saying ki, if I have a mask like this, and if I negate it, don't you think this will be the case? Hayana? So can I say the mask is nothing but over here negation of one left shift of n, and the answer is n or and mask. This will clear the ith bit. Can I say this? सही है? सबको यस लिख दो, सबको ओपी या फिर यस, जो मन करे लिख दो, अगर यहां तक पूरा क्लियर है तो. Perfect. My life course will be for 2 hours only. Like 2 घंटे का लेक्चर्स लूंगा, 36 क्लासेस दूंगा 2 आवर्स का. तो उधर 2 आवर्स के रख रहा है, 3 आवर्स नहीं रखेंगे. 3 आवर्स बहुत ज़्यादा हो जाता है. तो आई कीप इट फॉर 2 आवर्स ओनली. ठीक है? इधर थोड़ा सा क्राउड ज़्यादा है तो डाउट्स लेने में बहुत दिक्कत होता है. ओके, लेट्स. ठीक है, समझ में आ गया? So I think you have joined late. One left shift of I will make sure that this guy is set. Okay. Next one. Next one is very important because I think I'll just do some operations more. ठीक है. स्ट्राइवर का छोटा भाई, यस क्लियर है. ठीक है, स्ट्राइवर का छोटा भाई, मुझे ही नहीं पता था मेरे छोटे भाई हैं. मतलब आप लोग हो बट मतलब खुद का छोटा भाई कोई नहीं है, ये नहीं पता था. एनीवेज, लेट्स टेक अ क्वेश्चन व्हिच सेज कि रिमूव द लास्ट सेट बिट. आई वांट यू टू रिमूव द लास्ट सेट बिट. ठीक है, I want you to remove the last set bit. That is what my question to you is. Okay, let's see who can do this. That means if I'm giving you a binary something like this, okay, the last set bit is this. The last set bit is indeed this. I want you to remove this, which apparently will make this number as 110 1. The last set bit will be removed. That means it will be made 0, and yeah, the number stays 0. If I again ask you to remove the last set bit on this number, then this will be removed. Question clear hai? Question clear hai? कैसे करोगे? ओके ओके so that any idea on why that works? Like any idea on why that works? Probably if you have any idea, then throw in some light. Any idea? No for loops, no for loops. It's a very simple it's a very simple stuff. Now check the position of set bit using masking. नहीं एक लाइन में हो जाएगा, yes if you just do this that will work. If you just do this, that's going to work. If you just do this, that is definitely going to work. I'll tell you why this works. Let's take an example so that you can understand. Let's write 13. Okay, so 13 is 1 0 1 there's 13. Okay, so as I said, n and n minus 1, so n minus 1 will be 12. So if I write 12, that's 1 1, correct, and a 0 0. Now if I do an AND, if I end up doing an AND, what I'll get is 0 0, a 1 a 1. I will end up getting my last bit is unset. Like for an example, if I take 12 is 1 1 0 0. So what's the last bit? That's 1, right? So if I write 11 is nothing but something like this: 1 2 1, and this is 0. And if you do an AND, this will become 0, this will become 0, this will become 0, and this will become 1. So this will end up turning it off the last set bit. Got it? Clear hai? How do you clear the last set bit from the right? Is this clear? How do you clear? And the intuition behind this is very simple, because if I write a number like 8, 8 is basically written as 1 0 0 0. And if I write a number like 7 is actually having 1 1 1. This is the intuition behind this. Any number, any power of 2 is actually written as the powers of 2's before. Like for an example, 8 is not 8 is this, right? So what is 8? 8 is the power of 2. What is 7? All the powers of 2 before 8. That's 1 plus 2 plus 4. Correct? है कि नहीं? है कि नहीं? Yes, यही तो है, यही तो है. 16. What is 16? 1 0 0 0. What's 15? 1 1 1 1. What's 15 actually? 1 plus 2 plus 4 plus 8. Again, observe. चील की आंखों से देखो. 16 था. 15 क्या था? 15 है उसके सारे नीचे के पावर्स का प्लस 16 को छोड़ के, है कि नहीं? इसीलिए जब तुम n-1 करेगा तो देखो 12 का मतलब क्या था? 8 plus 4. 12 means 8 plus 4, so 8 will stay as it is. This 4 will take 1 less and this will happen. 4 was 100, so this turned up to 100. That's the logic, that's the intuition behind writing n and n-1. Clear intuition? Is the intuition clear? Is the intuition clear? In odd numbers it is very simple. If you subtract 1, the last bit will automatically be off. Yes. Odd numbers का तो intuition बहुत simple है यार. If you take any odd number and you subtract 1, the last bit automatically turns off, and when you do an AND it will automatically turn off, right? Clear हो गया? Perfect. Since any power of 2, उसके नीचे वाला जो power of, उसके नीचे का जो number होगा, it is actually written as summation of all. So वो automatically AND करोगे तो हट जाएगा. ठीक है? ओके, इंट्यूशन एक बार फिर से. चलो इंट्यूशन एक बार फिर से बताते हैं. मैं बताता हूँ, ध्यान से सुनना. अगर if there is a 8 is written as 1000, correct? Which bit is 8 having? This bit, right? In order to remove this bit, I just need to make sure that this is a 0, and this can be 1 1 1, whatever there can be, and these guys have to be similar, correct? So if I write a 7, that's actually 1 1 1, and this guy is made sure कि ये 0 होगा, right? So why is all of these 1 and why is this 0? Because whenever I'm talking about a power of 2, the right beneath number of that, the right beneath number 7 can always be written as 1 plus 2 plus 4. So these are powers of 2's that are lesser than 8. For example, 16 is 10000, but 15 is 1111, and 15 is nothing but all powers of 2 lesser than this, 1 plus 2 plus 4 plus 8. Correct? Now for example, if I take 12, what's 12? 12 is 1100. 12 is nothing but 12 plus 4. The moment you reduce 1, it becomes 11, which is what? तुम 4 को तो तोड़ोगे ना. 4 का नीचे वाला कैसे टूटेगा? अभी तो बताया. जो एक नीचे का पावर है कैसे टूटेगा? अभी तो बताया. 1 plus 2, अभी तो बताया, है कि नहीं? तो इससे क्या होगा? ये वाला जगह 0 हो जाएगा एंड ये दो जगह 1 हो जाएगा. इसीलिए जब तुम ऐड करोगे ये और ये आपका 0 हो जाता है. गॉट इट? In terms of odd numbers, it's a very simple intuition, because 1101, the moment you reduce 1, it is automatically make sure that this is turned off. The last bit. Whenever you reduce 1, that's automatically turned off. And in case of even numbers, the last power of 2 is broken down into smaller powers of 2's. Got it? Got it? Is the intuition now clear? अभी क्लियर है? इंट्यूशन बता दो. सबको समझ में आ गया? Everyone. I want a yes from everyone. Yes. Okay. परफेक्ट। मेरे क्लास में ओपी लिखा करो, मतलब यस यस के जगह ओपी लिखना अच्छा लगता है मेरे को भी। ओके कूल। सो अभी आते हैं अपन सबसे नेक्स्ट क्वेश्चन पे। इसके बाद एक क्वेश्चन करेंगे एंड फिर बाकी के जो क्वेश्चंस हैं वो कल तो मैं कहीं थोड़ा जा रहा हूँ बाहर घूमने, हाँ मैं जा रहा हूँ घूमने फिर से, और संडे आ जाएंगे सो संडे करेंगे, ठीक है अपन संडे करेंगे। थोड़े प्रॉब्लम्स हैं, 1 घंटे का और सेशन लेंगे, थोड़े से प्रॉब्लम्स कोड फोर्सेस से करेंगे, थोड़ा उधर से करेंगे, थोड़ा सीखेंगे पावर सेट, थोड़ा और कॉम्प्लेक्स लॉजिक बिट मैनिपुलेशन का, विल डू दैट ऑन संडे, ठीक है कूल। सो next question, or how to check if a number is a power of 2. I think everyone can do this now. If a number is a power of 2, how to check if a number is a power of 2? How do you check if a number is a power of 2? How to check if a number is a power of 2? हाँ घूमेंगे घूमेंगे। फॉर ऑल अपडेट्स आप मेरे को इंस्टाग्राम पे फॉलो कर सकते हो, you'll get to know. Yeah, any power of 2, for an example, like a number like 16 will always have a bit set, a number like 8, but what's the shortest way to check it? What's the easiest way to check it? मैंने आज तक लाइफ में एक गेम नहीं खेला है, मैं गेम क्या स्ट्रीम करूँ, ट्रस्ट मी टिल डेट मैंने एक गेम खेला था 8 बॉल पूल जब आया था, उसको छोड़ के मैंने लाइफ में आज तक कोई गेम नहीं खेला है। हाँ रोड रैश खेलता था बचपन में, उसको छोड़ के कोई गेम नहीं खेला है। Okay, yes. Again, as I told you, if this is your power of 2, if you subtract 1, this makes it 1, 1, 1. Right? And if you do an AND, all these things will be 0, isn't it? So can I say, if n and n minus 1 becomes 0, can I say my answer? Yes, is a power of 2, or else it is not. Perfect. Perfect. We go fun again. सही है। अभी फटाफट लास्ट क्वेश्चन करते हैं फॉर द डे एंड देन आई विल रैप इट अप। भूख लग गया मुझे, खाने भी जाना है। तो नेक्स्ट क्वेश्चन करते हैं, काउंट द नंबर ऑफ सेट बिट्स। काउंट द नंबर ऑफ सेट बिट्स इन अ नंबर। काउंट द नंबर ऑफ सेट बिट्स इन अ नंबर। बाय द वे सेशन किस चीज़ में था, C++ या जावा? आज का सेशन कौन सा लैंग्वेज पे था, C++ या जावा? एंड विच लैंग्वेज वाज टुडेज सेशन, C++ or Java? What do you think? How do you count the numbers of set bits? For an example, if I give you something like 14, this is 1 1, I think 1 0. So the number of set bits is actually 3. I wanted to print 3. भाई कौन CPP बोल रहा है, मैं कैमरा में घुस के तुमको उठा के ले आऊंगा। जो C++ बोल रहे ना, मैं उसको लाइक whoever is saying na C++, I'll get into the camera and bring you off. And no language, man. I generally teach in this way. I don't focus on language. Okay, so you need to figure out the number of set bits in a row. Okay, you need to figure out the number of set bits in a row. So how do you figure out the number of set bits? That is the simple enough question. So what I can do is, the first way is very simple. What you do is, you write while, okay, and you write n not equal to 0. This is the first way. And inside this you say, if n and 1 is equal to 1, you do a counter plus, okay, and you do n equal to n right shift of 1, and at the end you can print count. Okay, so abhi count is 0. So let's first understand this. Let's discuss a bit of complexity, then we will move to the optimal solution. So if n is 14, let's assume n is 14. So the first line executes 14 and 1. So if 14 is 1 1 1 0 and with 1, this gives you 0 0 0 0. So as I said, 14 and 1 will make sure the last bit is set or not. We'll check it out. Okay, so can I say the last bit is not set, hence the counter will not increase. At the next step, what will happen? N says, can you just right shift yourself by 1? So when this guy right shifts itself by 1, this becomes 1 1 1 0, right? This becomes 0 1 1. Perfect. Next again it comes, and this time it is 0 1 1 1, and I do an AND with 1, and I find it as 1 0 0 0. So I say the bit is set, hence the counter, which was initially 0, now becomes 1. Okay, now again I do n right shift of 1, so I say again right shift of 1, so this becomes 1 1 0 0. In this way I will be right shifting right shifting right shifting, and at the end of the day the count will be 3. But what is the complexity of this loop? Can you tell me what is the complexity of this loop? What is the complexity of this loop? इसकी कॉम्प्लेक्सिटी क्या है? इसकी कॉम्प्लेक्सिटी क्या होगी? Can I say the complexity of this will be big of, if it's an int, like whatever is the total number, like last जो set bit होगा, wherever is the last set bit, can I say this is going not log n, can I say big of number of bits? The big of number of bits will be a better representation, like the number of bits. Like over here it was 1 2 3 4, so we have to run it 4 times. You have to run it, like I can say position of the most significant bit, position of the most significant bit. Okay, so can I say it's the position of MSB, wherever, like wherever is your MSB. Okay, so that's what you can say. But can I reduce this to something better? Like not better in all cases, but yes, I can do something better. For an example, as you know, if the number is 14, right, and I write something like this, while, and what if I just keep on turning on the right bits? Like let's take any other number, like, oh sorry, okay, let's take 13. Okay, 13 लेते हैं. And I wanna 13 is 1 0 1 1 0 1. Let's turn this bit off, and then I'll make it 1 1 0 0. Let's turn this bit off, I'll make this as 1 0 0 0. Let's turn this bit off, this will be 0 0 0. So it's a step 1, it's a step 2, it's a step 3. So there are 3 steps involved because there were 3 bits. So first you turned off the rightmost bit, then the next rightmost bit, then the next rightmost bit. So how can you do that? So can I say I will be iterating till n is not equal to 0, and at the end of the day, can I say I'll always make sure that I'll turn off the rightmost bit, which is equivalent to saying n and n minus 1, which we have already learned. And can I just keep a counter which counts the number of times I am turning off the rightmost bit, and at the end of the day I can print the count. So what will be the complexity? Can I say the complexity will boil down to number of set bits? But is it a very good complexity? No. Like for a number like 15, we have something like this. For a number like 15, we have something like this. So both the methods will yield the same time complexity. Both the methods will actually have the same time complexity. So can I say keys दोनों ही same है, but हाँ, this is slightly optimal for certain test cases because it's a big O of set bits. Clear है? Is this clear? Is this clear, guys? स्ट्रीम लाइक कर दो स्ट्रीम लाइक कर दो. Just give me OP in the chat if you've understood this. Give me OP in the chat if you've understood this so that I can definitely. So what will be tomorrow's class, like sorry, Sunday's class composing of? So Sunday's class will be composing of some problems. I'll be teaching you how to print all the subsets, which will be using the power set logic. I'll be doing one problem which says ki every number actually appears twice. Every number appears twice. Every number appears twice and two numbers appears once. So two numbers, not one, two numbers appears once. So I have to figure out those two numbers. ठीक है, अभी लास्ट जो क्वेश्चन रहेगा और एक क्वेश्चन रहेगा, you have to implement the set data structure using bit set. Implement the set data structure using bit set, given the numbers range are from 0 to 60. To implement the set data structure in bit set. The next one will be print all subsequences whose sum is equal to k. So this is what will be taught tomorrow. Sunday. Sunday probably 9 और 10 बजे मैं करवा दूंगा स्ट्रीम. 9 या 10 बजे को एक तो टाइम चूज करेंगे, स्ट्रीम कर लेंगे. ठीक है, 9 बजे कर लेंगे. इज 9 ओके? समराइज नहीं कर सकते, वापस देख लेना. ठीक है, सो मेक श्योर यू गिव द स्ट्रीम ए लाइक. एंड कोई भी बिट मैनिपुलेशन पूछता है कहाँ से पढ़ना है, सो मेक श्योर यू टेल देम कि ड्राइवर भैया का ये लेसन है, इधर से जाके देख लो, पूरा पानी की तरह क्लियर हो जाएगा. ठीक है, चलो गाइज आज के लिए इधर ही समाप्त करते हैं. मिलते हैं संडे 9 बजे या 10 बजे, कौन सा टाइम करें? आप लोग बताओ. विच टाइम डू यू वांट, 9 और 10? यू टेल मी, आई विल डिसाइड. विच टाइम डू यू वांट, 9 और 10? जिसका भी वोट होगा उसी पे करते हैं. कोड फोर्सेस है तो ठीक है, अभी थोड़ा जल्दी कर लेंगे. अगर कोड फोर्सेस कितने बजे है? कोड फोर्सेस कितने बजे है? कितने बजे कोड फोर्सेस? when is the code forces round? कोड फोर्सेस कितने बजे संडे को? कोड फोर्सेस कितने बजे है? कोड फोर्सेस कितने बजे ये बताओ. ठीक है, we'll keep the class at 10 o'clock. Since everyone is saying 10 o'clock, I'll keep the class as 10 o'clock. I'll check out the timings of the code forces and I'll keep 1.5 hours before that so that you can watch the class, and for people who want to go and participate in code forces, they can definitely do it. ठीक है, चलो guys, bye bye, take care, good night. And follow me on Instagram if you're wishing to, and subscribe to this channel. Ta-da.